Hi everyone, this video is on exercise 9 and question 4 of PO2. We have the function 2x squared ln x, and we want to show that f has exactly one point of inflection. So if you want to find the point of inflection, you first need to find the second derivative of the function and then set that to 0 and solve that equation to get a value, at least a value for x. And then you are going to what you need to do afterwards is analyzing the behavior of the function at just before and after each of those x values that you get. And by doing these two steps, you can find the point of inflection. Now in this case, we are first going to find the second derivative of the function. So f dash x is equal to, remember it's a product rule because we have two different functions. So I'm going to write down the first function times the derivative of the second function. Ln x differentiates to 1 over x plus the derivative of the first function, which is 4x, times the second function, which is ln x. And we can simplify this. So we are going to get 2x plus 4x ln x. And for the second derivative, so 2x differentiates to 2. Again, we have another product rule, 4x and ln x, two different functions. So the first function is 4x times the derivative of ln x, which is 1 over x, plus 4x differentiates to 4 times ln x. And now we can simplify. So we have 2 plus 4 plus 4 ln x, which is equal to 6 plus 4 ln x. This is the second derivative. And the next step is solving this equation. So f double dash x is equal to 0. We have 6 plus 4 ln x is equal to 0. And so we can subtract 6 from both sides to get 4 ln x is equal to minus 6, which then can be written as ln x is equal to minus 6 over 4. And we can use e. So e of ln x on one side and on the other side e of minus 6 over 4, which gives us x is equal to e to the power of minus 6 over 4. So this is the x value that I was talking about at the beginning of the video. In this case, we only get one value for x, but it's also very possible that to get multiple values of x. And if you just read the question carefully, it says that determine the value of x at that point. So we have already done that. But we also need to now answer this part, which says show that f has exactly one point of inflection. We have done most of the steps that we needed to do, but there are still a few more. Because now we have the conclusion that there is only one value for x, which aligns with what we have here, that there is one point of inflection. But now we haven't, the thing is, we haven't completely shown that x is equal to e to the minus 6 over 4 is the point of inflection. So you might have done these questions before, and a very important part is that once you find the value of x, you then need to analyze the behavior of the second derivative, the function, the second derivative of f double dash x, just before and after that x value. So this allows you to basically prove whether that's the point of inflection or not, because a point of inflection is a point that the curve changes from being concave to convex or vice versa. But it's not all the time the case, because there are cases that you get some x values as a result of solving f double dash is equal to 0, but they are not the point of inflection. So in order to check that, we are simply going to check the value of f double dash x at just after the value of x that we found, and also just before that. So what I mean is that we find f double dash x of x, which is e to the minus 6 over 4. But when I said just after that, means adding a tiny amount to that. And also when I said just before that, means subtracting a tiny amount from that. This allows us to see if the sign changes, because that is an indicator whether the curve has changed from being concave to convex. So what we are aiming is to get a negative value for one of them and a positive value for the other one. But there are some cases that will end up getting two positive values or two negative values, and in those cases that means that point is not the point of inflection. Okay, now it's all about using calculator to find these values. Okay, so for the first one, which is adding 0.1, we'll get 1.481 to 3 decimal places. And for the second one, we get minus 2.378 to, again, 3 decimal places. And this is exactly what I was talking about. So we basically got two values with different signs. So one of them is positive, the other one is negative. And this simply means that we can conclude that hence x hence this is the point of hence we have a point of inflection with x coordinate e to the minus 6/4. Normally in questions like this we are expected to find the y coordinates, because when they say find a point of inflection, that means you also need to have the y coordinates, because what you get from the equation is the x coordinate, and in order to get the y coordinate you substitute this x coordinate into f of x. But in this case what they have asked is just the value of x at this point, so there is no need to find the y coordinate. Okay, so that's it for this video, and thank you for watching.